and welcome back to my channel. This particular channel is about measurements and instrumentation. So in the previous lecture, this is my fifth lecture. In the previous lecture, we have this. Sorry, this is my sixth lecture. So in the previous lecture, I discussed about the different operating the effects which help in the movement of the deflection of the pointer in analog meters, and after that I discussed about the different forces. Yeah, different operating forces. I discussed this in the last video. Now I will move on to another effect, which is the damping system. See, we have discussed deflecting system. We have discussed about the controlling system. Now we'll discuss about damping system, which is again very important uh, for getting the output of the system of the quantity which we are measuring. So to get the value of the quantity which we are measuring, will require damping system. So next I will discuss about damping system. Okay. So damping system, as I had explained earlier, it is the system which helps in damping the movement of the pointer. The pointer is deflected with the help of deflecting torque or deflecting force. It is controlled with the help of controlling system that provides the controlling torque or the controlling force. Then comes the damping system, because the system has to damp somewhere at some particular value so that we can get the output, we can get the value of the quantity being measured, the quantity, number, the value of the quantity being measured we can get. So for that, damping system is very important. Now damping system, for damping the system we need damping torque. Okay, so these are provided by four damping systems: air friction damping, fluid friction damping, eddy current damping, and electromagnetic damping. So let us discuss one by one the damping systems. So the first system is air friction. First damping system considers air friction damping. Now I will explain what is air friction damping. So this is the diagram of air friction damping which is applied in analog meters. What are there in this construction? Let us see. You can see there is a pointer which gives a deflection. Okay, this is the scale over which the pointer moves, which at the value at which the scale at which it will stop will give us the quantitative value. Okay, this is the pointer, this is the spindle upon which the pointer rotates, and this is a piston. Okay, this is a piston which is connected to the pointer. See, this is a piston which is connected to the pointer. Now where is this piston placed? The piston is placed in an air chamber. This is an air chamber consisting of air, or you can say it inside it air is there, or very less amount of air is there, so vacuum you can say. So the piston is there in this chamber. Okay, and this piston, this side is closed and this side is open, with this only the piston going and coming out of the opening. Now how it works? See, whenever this pointer moves from the initial position, the pointer is attached with the spindle and this is attached to the piston. Suppose the pointer is initially at 0 position. Okay, it will deflect, so let it be in some position here. Okay, so and due to which when it will move this way, see, when the pointer moves upward, this piston will come outward, right? And whenever the pointer comes downward, the piston will be moved inward, right? Now see, suppose the piston is moving upward. If the piston is moving upward, then this piston, sorry, if the pointer is moving upward, then this piston will be coming outward, right? Once the piston comes outward, see, there is air present in the chamber. This is air chamber, air is there in the chamber. So what will happen? This whole area is covered with air. But when this piston is coming downwards, then in that small area only this piston is moving. So what it will do, it will compress the air, right? It will compress the air, isn't it? It will compress the air. The pressure at this area will be lesser than the pressure at this area. But at normal position, at equivalent, uh, at equilibrium, the piston is at such a position where the pressure is evenly distributed. But once the pointer moves, the piston will come outward and the air pressure at this area increases compared to the air pressure of this area, right? Now this imbalance is caused, right? This imbalance will try to push the piston to its original position. Because this equilibrium, it will try to keep itself in equilibrium state. So it will push the piston to its initial position. So what will happen? The piston will go upward, again it will come downward, again it will go outward, and it will be settled at such a value at which the equilibrium air pressure is attained in the air chamber. Is it okay? See, the piston, I am assuming that the piston is in this central position. After the movement of the pointer, the piston has come to the central position. Once the piston comes to the central position, the air pressure at this area and the air pressure at this area are not same. Here it will be more because in small area more of air will be there, which will be subcompressed, which is compressed by the piston. And in this area pressure is very less, so there is an imbalance between the pressure, and but the system always try to keep itself in equilibrium position. So the air pressure created here will try to push the piston to its original position, so that the equilibrium is attained in the air chamber. So it will go inside, come outward, go inside, come outward, and it will get settled at such a position where this equilibrium is attained and the air pressure is evenly distributed in the system. At that position the piston will be settled down, right? Once the piston settles down, the pointer which is attached to the piston will also be settling down. So this is air friction damping. This is occurring due to the air and friction between the piston and the air, right? So this is air friction damping. The pointer attached to the piston, when the pointer moves, the piston moves. So if I am considering a position when the piston is in the central position because of the movement of the pointer, then the air pressure at this area is more compared to this area, and hence the air pressure created here will push the piston to its initial position. It will try to push it to such a position where the equilibrium can be attained again, so that the equilibrium is attained again. Once the equilibrium is attained in the chamber, the pointer gets fixed or settled at such a position. Now this equilibrium, again the movement of the piston will depend upon the input quantity. How much is the current, how much is the voltage, upon that it will depend. Okay, so this is air friction damping. Now let us move on to fluid friction damping. Like in the previous case, air friction damping, air was there and friction was there, and due to the air friction damping was caused. Same case, fluid friction damping. So in case of air friction, air was there. So what will happen in case of fluid friction? Some kind of fluid will be there. So here is a container consisting of a damping oil. Now what should be the nature of damping oil? The nature of damping oil should be very thick, so that it resists the rotation of the wind. Now I am explaining what is that. There is a reservoir in which oil is there, okay, damping oil is there, and in this damping oil the piston, one spindle is there to which the pointer is connected, and the spindle, at the other end of the spindle a disc or vane is attached. A disc is attached. So a disc is what? It is a solid thing that whole setup is immersed in a damping oil. The property of damping oil should be, the viscosity should be what? The viscosity should be such that it opposes the movement of the disc. So the it should be thick in nature. The oil should be thick in nature. So with this spindle, the pointer is connected. Once the pointer starts rotating, it will help in movement of the this piston, right? When it moves the pointers, suppose the pointer is this, here it is the pointer. If it rotates in the clockwise direction, then this spindle will also try to rotate. Once the spindle rotates, the vane or disc which is connected to the other end of the spindle also rotates. But this rotation of the spindle is opposed by the damping oil because of its thickness, its viscous nature. It will oppose the movement of this disc. So the opposition of this damping oil provided to the disc will help in bringing the spindle to steady position, because the oil will not let the disc rotate. If the disc is not rotating, the spindle will not rotate, and if the spindle is not rotating, then the pointer will stop rotating, right? So this is how fluid friction damping takes place. There is a reservoir in which damping oil is there, spindle is there with which the pointer is connected, and at the other end of the spindle, disc is connected. The whole system, it is immersed in a damping oil. Once the pointer starts rotating, it will rotate the spindle. Once the spindle rotates, it will rotate the disc. Now disc is placed in a damping oil. Once the disc starts rotating, the damping oil will provide a force in the opposite direction, which will not help in rotation of disc, rather it will stop the disc from moving. So the disc will stop rotating. Once the disc stop rotating, spindle will not rotate, and the spindle, if the spindle is not rotating, then the pointer will not rotate, and it will come to a steady position. So the damping has happened, the damping has occurred. So this system is known as fluid friction damping. Next damping system is known as eddy current damping. Okay, I forgot to mention the name. This is eddy current damping. Now what happens in eddy current damping? See, this is a damping magnet, and this is a aluminum disc which is attached to the spindle. Okay, this aluminum disc is attached to the spindle, and with the spindle the pointer is connected. The pointer is connected over a scale. Okay, so when the measurement is applied, when the current or voltage or whatever the quantity is applied, the pointer will deflect because of the forces discussed, right? It will deflect. Once this deflect, this spindle will start rotating. Thus disc is connected to the spindle, right? Now see, the disc is placed where it is placed in between damping magnet. There is a magnet which is known as damping magnet. So there will be a magnetic field here between these two ends of the magnet. This end, North Pole and South Pole. Between North Pole and South Pole, definitely one magnetic field will be there, and this aluminum disc is there. So if the aluminum disc starts rotating, see, once this aluminum disc is placed in between this magnetic field, then here there will be a production of EMF, right? Due to the production of EMF, there will be flow of a current which is known as eddy current, which flows over a metal surface when EMF is induced in it. So there will be production of eddy current. Now that production of eddy current will again it will develop a different magnetic field, because current produces magnetic field. Any conductor having in which current is flowing, it produces its own magnetic field. So there will be a force due to the magnetic field produced by the the eddy current, and a magnetic field which is there due to the damping magnet. The interaction between these two forces will lead to the stopping of the aluminum disc. Why? Because the production of EMF, it is due to the whatever is the cause. The cause of this movement of aluminum disc is the movement of this spindle. So whatever is the cause, it is rotating, right? And that rotation is stopped by the magnetic field of the damping magnet. So whatever is the cause, the cause, as I said, is the movement of the aluminum disc, which is due to the movement of the spindle. So it will try to nullify the cause. So it will stop the spindle from moving. First it will stop the aluminum disc from moving. It will, once the aluminum disc stops rotating, the spindle will stop rotating and the pointer will hence stop rotating. So this is the eddy current effect or the eddy current damping method. Why? Because eddy current, production of this eddy current in the disc will help in production of a torque due to which the aluminum disc rotates, and the rotation of aluminum disc is opposed by the magnetic field between the damping magnet. So it will try to damp the cause, it will try to nullify the cause. So cause is the movement of spindle, so it will try to stop the movement of the spindle or movement of the this thing, the aluminum. Next is electromagnetic damping. So what is electromagnetic damping? Whenever a conductor rotates in a magnetic field, then the magnetic flux linked with it changes, which induces an EMF, right? Whenever a current carrying conductor, we say, rotates in a magnetic field, then whenever a conductor is placed in a magnetic field, or whenever a conductor is rotating in a magnetic field, whenever a conductor is rotating in a magnetic field, then due to this change in the number of fluxes linked with the conductor, an EMF is induced, right? Del phi dt, that EMF is induced. If the circuit is complete, now if the circuit is completed, then what will happen? A current will flow. Then the induced EMF will produce an induced current. According to Lenz's law, the direction of induced current will be so as to oppose the cause of its production. What is the cause of the production? The cause of production is the movement of the conductor. See, the conductor is rotating. Where it is rotating? It is rotating in a magnetic field. Okay, conductor is rotating in a magnetic field. So the conductor, it is experiencing change in flux. That change in flux will give rise to production of EMF. Now if the circuit is completed, that EMF will lead to flow of current. So that current induced will be such that direction of the induced current will be such that, according to Lenz's law, the direction of the current induced will be such that it opposes the cause of the production of current. Now what is the cause of production of current? The cause is the rotation of the or movement of the conductor. So it will try to it will try to stop the conductor from rotating. So what it is written, the direction of induced current will be so as to oppose the cause of its production, which is rotation of conductor, hence the conductor stops. So this way the electromagnetic damping is used. Okay, I hope it is clear. Now I am repeating once again. Whenever a current carrying conductor is placed in a magnetic field, whenever a conductor is moving in a magnetic field, that moving conductor, there will be some EMF induced in the conductor because of the change in magnetic flux it is experiencing. So the EMF is induced. Once EMF is induced, if the circuit is complete, then current will definitely flow. Now the direction of that current which will flow will be so as to oppose the cause, according to Lenz's law. So the cause is the rotation of the conductor, or cause is the movement of the conductor. So it will try to stop the conductor from moving. So in this way the conductor stops, and hence the damping of the system has taken place. Okay, so this is electromagnetic damping. So these are the four types of damping techniques, damping systems, which I was about to discuss. Air friction damping, in which air friction is used; fluid friction damping, in which fluid friction is used; eddy current damping, in which the eddy current developed in the aluminum disc is used; and electromagnetic damping, in which the current developed or current flowing in an electromagnet is used for damping. So this was all about damping systems. Now I will move to systems. Till now we were talking about different types of analog, the analog instruments. But what we discussed about the different types of uh, forces, which the effects which due to which the um, we get readings of the quantity being measured. So the forces helped in deflection of the pointer. Then the controlling force was there, control system was there. What are the two types of control system? Those were discussed. Then after that, different the damping system were discussed, because damping force is required to get the output. So damping systems discussed, and the different types of damping systems have been discussed. Now all these things we have known about analog instruments. Now we'll talk about analog instruments. What are the different types of analog instruments present? These are the various types of analog instruments present. PMMC type instrument, that is permanent magnet moving coil instrument; moving iron type instrument; electrodynamometer type instrument; hot wire type instrument; thermocouple type instrument; induction type instrument; electrostatic type instrument; and rectifier type instrument. So all these instruments will be discussed one by one in the coming days. So first is uh, permanent magnet moving coil. So there is a permanent magnet, there is a moving coil, as the name suggests. Then moving iron, where some iron will move. Electrodynamometer, some electrodynamometer type instrument will be discussed. Then hot wire type instrument, thermocouple type instrument. These two will be discussed. Induction type instrument, induction effect I have discussed, and I told that these techniques are used in development of some instruments. So this is induction type instrument. Electrostatic I have discussed. So electrostatic type instrument, then rectifier type instrument. So these are the various types of instruments which will be discussed in the upcoming classes. Now let me give a very brief idea about what is permanent magnet coil instrument, which is also known as PMMC instrument. Okay, permanent magnet. So in the system, first let me tell you the construction of permanent magnet coil instrument. Permanent magnet moving coil instrument, it should have been. Okay, so as the name suggests, there is a permanent magnet north south. This is a permanent magnet. There is a moving coil. This is the moving coil. Okay, so what are there? There is a permanent magnet, there is a moving coil, there is a spindle. Okay, the spindles are connected over jewel bearings, we say, pivoted on a jewel bearings. Then spring is there. I will tell the application of each and every part one by one. Balance weight is there. This is the pointer, and this is the mirror scale. Okay, and what else are there? Coil and former, permanent magnet, and core. Yes. So this is the construction of permanent magnet moving coil instrument, or PMMC instrument. Now how does it work? Permanent magnet moving type instrument, how does it work? Uh, Permanent magnet, it is there to develop the magnetic field. Okay, to provide the magnetic field, permanent magnet is used. Okay, coil is required because we want to measure some quantity. The input quantity is fed to the coil. Okay, so coil is required. Now coil is always bound on some thing, some solid thing, that is known as former or core, upon which the coil is wound. Okay, that is called known as core. Balance weight, just to uh, balance the deflection of the pointer, one weight is always connected to the other end of the pointer. Spring, why spring is required? As I discussed in the previous lecture, Spring control mechanism is there to control the deflection of the spring. So if spring is there, that means spring control is used here. Okay, not gravity control. Spring control is being used for controlling the deflection of the torque. One thing is missing, that is the damping thing, and damping here it is used as air friction damping. Okay, now how does it work? What happens, this is a magnetic field, right? North pole and south pole. Whenever north pole and south pole is there will definitely be some magnetic field, right? So there will be some magnetic field. See, this is pole, this is the coil, and this is the former upon which the coil is placed. Okay, so this magnetic field will be there between the two poles of the magnet. So it will have a magnetic field. So what is happening, magnetic field, in this magnetic field a coil is placed. Now see, the coil, the quantity being measured is passing through the coil. So if the quantity being measured normally are what, current. So once the current flows through the conductor, what is the scenario? The scenario is that a permanent magnet is there which is providing the magnetic field, and in a magnetic field a current carrying coil is placed, right? In a magnetic field a current carrying coil is placed, because this coil, to this coil an input will be there, an input current will be fed. So there is a magnetic field and there is a current carrying coil. So whenever a current carrying coil is placed in between in a magnetic field, then the coil experiences a force, right? Once the coil experiences a force, it will start rotating. Once it start rotating, with the coil, see, with the coil spindle is connected, right? The spindle is connected to the coil. Once the coil starts rotating, the spindle rotates, and the pointer which is connected to the spindle also starts rotating. So this way we will get the deflection. Now the deflection of the pointer will be controlled by this spring which is attached to the spindle, and the deflection will be there, and it is controlled by the spring, and there will be a damping system also which will damp the movement of the pointer. So the main thing is what, north pole south pole is there, magnetic field is there, current is applied to the conductor, current flowing conductor is placed in a magnetic field. Whenever a current carrying conductor is placed in a magnetic field, then the coil experiences a force. Due to that force a torque will be developed and this coil will start rotating. The coil starts rotating, so the spindle connected to the coil will also rotate, and the spindle rotates, the pointer connected to the spindle will also move, so the pointer moves. The movement of the pointer is connected by the spring which is connected to the spindle, and the to damp the pointer, one damping system is also used here, air friction damping is used. Okay, so this is the basic working of PMMC instrument. This is the construction I have told you, working principle I have told you. This is how the how a PMMC instrument work. Now there another important thing, torque equation of this PMMC instrument, that I will discuss in the next lecture. Up to this, in this lecture I will stop up to this the construction and working principle of PMMC instrument. In the next lecture I will discuss about the torque equation of PMMC instrument. Okay, so thank you for watching, and please do like and share my video, and you can also put comment. If you have any doubt you can ask questions. You are welcome to ask question, I will answer for sure. The rest part I'll discuss in the next lecture. Thank you very much for watching.